Hi! In the last video, we looked at clear coat and sheen effects for materials. And this time we're going to look at transparent materials. That is glass, glassware, refraction, translucency, transmission, and a number of other effects that make glass more realistic in real-time applications and in the web. So here we have a couple of different types of glass as seen in Needle Engine. So here we have a dispersion effect where you get rainbow-like effects on the edges of glass, or refraction and attenuation where you can see that the glass is colored by the depth that the light travels through it, or refraction of the scenery behind it, as you can see here. There's also what's called thin-walled glass, like you would have in soap bubbles or some very fine glassware, where you don't really get to see a refraction, like you can look straight through it, but you still get the glass-like appearance. This is, for example, used for windows most of the time because these are comparably flat and you can look through them without seeing much of a refraction. Glass can also be coated, like you can combine it with the clear coat effect we saw last time, which is pretty much what a lot of mobile displays and laptop screens and so on do by now. They have a reflective layer for the screen, and then they coat it with something matte so that less light is reflected. And there's also rough refraction, where the glass is not fully transmissive. You can see that it has a rough structure like milk glass. The materials we just saw are all real-time, all live in the web through Needle Engine, and I'm going to show you how to author them in Unity and then export to the web with Needle. We're going to start with a default material. This material uses the Unity GLTF PBR graph shader, which allows us to bring a lot of the sophisticated material model that GLTF has into Unity for easier fine-tuning. The same properties are going to be available in Blender or other softwares depending on where and how you set up your 3D files and materials. Now, if we scroll down on this material, we have all the options that we can turn on here, and we're going to turn on transmission. And that gives us new sliders. So for example, a transmission slider. And if we turn that all the way to the right, we can see that we already get a rough refraction here because we had set the material to be rough before. If we turn the roughness all the way down, we get clear glass. It's still a bit tinted because of the default color that was set here, but we can adjust that to be any type of glass that we want to have. Now you can see that this doesn't look like an orb of glass. It looks more like a thin layer. And that's what I mentioned earlier. Like this is the so-called thin-walled glass effect where you don't get any refraction effects for the scene behind it. And we can change that by enabling another feature of the GLTF material, which is volume. Volume and transmission work together to give you refractive glass and other refractive materials. Now that we have volume turned on, there's new sliders. For example, there's thickness now. And thickness is what turns this from a thin-walled glass with thickness 0 to something that refracts the scene around it. You can see that while I drag on the thickness slider here, we can see that the scenery starts getting refracted in our glass object. We can make this a little bit more visible by changing this inner shape here to, for example, a matte dark or shiny dark material. Or to make it even more visible what's going on, we can change it to some grid-like material. And here we can see that this inner sphere is refracted in the glass sphere around it. Now, if we turn our thickness back to 0, and then slowly start increasing it, you can see what's going on all the way up to a level where this would be a solid piece of glass that is refracting the environment in a harder to understand way. All the way up to like a solid piece of glass. For more complex objects, you often end up having a so-called thickness map, where you can specify an approximation of how thick the object is in various places so that you get the right effects in terms of glass as well. Now, there's more parameters that influence how this looks. And one is the so-called Index of Refraction. That property controls how light goes from one surface to another that are different types of materials, like from air to glass, from one type of glass to another, and so on. You can see that even if we have a thickness value, if we put the index of refraction at 1, we're basically telling the material that there's nothing going on from one surface to another. Now it's essentially made out of shiny air. But if we turn the index of refraction way up, we can see that the glass starts looking more dense. And that intuition also shows in the fact that the more dense a piece of glass is, like the stronger the material is, the higher the index of refraction is. And you can see that in kitchenware quite often. If you have a cheap piece of glass, it's going to have a lower index of refraction and it's going to look somewhat less nice. And if you have high quality glass, it's going to have a higher index of refraction, all the way up to something like 2.3, which is the index of refraction of diamonds. So they bend the light in a particular way that we have learned to kind of see. What we can also tune is the roughness of our material. And if we adjust that, we can see that we get a rough glass effect here. What's interesting is that when we turn up the metalness, the metallic factor, then we can see that our glass effect starts disappearing. And that's just physics at play. There is no transparent metal. Like metals are too dense, they reflect right below their surface. So a physical material can't be at the same time a pure metal and transmissive. Of course, for artistic effects, we can do that here. We can kind of mix between a metal effect and a transmissive effect, but it doesn't quite look like some material from this world. Another relevant property here is attenuation. And attenuation is the effect of light tinting while it goes through a layer of glass. So what we can do here is we can set an attenuation color and an attenuation distance. And the higher this attenuation distance is, the longer light can travel through that piece of glass until it gets colored. And so if we tune this, we can see the effect is comparable to what you see in a glass of wine, where the more wine is in the glass, the more red it gets as the light travels through it. And of course, all of these effects can be combined again. So we can have a rough refraction in glass, but add a thin layer of coating on top of it. So now you can see we get the rough behavior inside of the glass and then nice reflections on top of it. Now, if we export this scene to the browser, where we have all of our other test materials as well, we can see that we get very interesting light effects with light going through the glass, getting colored, but also having a coating layer on top. And depending how you tune these effects, you can get colored glass, different kinds of refraction strength, thin glass, rough glass, all that kind of stuff. And due to the parameters being so flexible, you can go pretty crazy and design materials that feel realistic because they're all grounded in a physically based material model, but don't quite look like something that you know from the real world. And if you combine this with textures, you can create even more varied effects. Like here, for example, we have a map that controls the roughness and the transmission of the surface. So we get some parts that are clear and other parts that have a matte refraction to it. That's it for this video, and see you next time.